Welcome everyone to Lightning Basics 101. We have done Tornado Basics 101. We have done Thunderstorm Basics 101. Now, it's time for Lightning Basics. Now, in the background, we do have lightning, thunder, and rain. If you have not seen this video right here, then you are missing out. Behind me is one lightning flash striking across, hopefully, if I can get this to color out, but what credits NOAA and NSSL? What is lightning? Lightning is a giant spark of electricity in the atmosphere between clouds, the air, or the ground. In the early stages of development, air acts as an insulator between the positive and negative charges in the cloud and between the cloud and the ground. When the opposite charges build up enough, this insulating capacity of air breaks down and there is a rapid discharge of electricity that we know as lightning. The flash of lightning temporarily equalizes the charged regions in the atmosphere until the opposite charges build up again. Lightning can occur between opposite charges within the thunderstorm cloud, intra-cloud lightning, or between opposite charges in the cloud and on the ground, cloud-to-ground lightning. Now, cloud-to-ground lightning is very, very dangerous. So, when your National Weather Service calls for a severe thunderstorm warning, get inside. When you hear thunder or lightning, get inside. Lightning is one of the oldest observed natural phenomena on Earth. It can be seen in volcanic eruptions, extremely intense forest fires, surface nuclear detonations, heavy snowstorms, and large hurricanes, and obviously thunderstorms. What we do, which obviously there's a link there, we can't push it because it's on paper. What causes thunder? Lightning causes thunder. Energy from a lightning channel heats the air briefly to around 50,000 degrees Fahrenheit. Much hotter than the surface of the sun. This causes the air to explode outward. The huge pressure and the initial outward shock wave decreases rapidly with increasing distance and within 10 yards, or so has become small enough to be perceived as a sound we call thunder. This is the sound thunder that we hear. That is thunder, if you don't already know. The thunder can be heard up to 25 miles away from the lightning discharge, but the frequency of the sound charges with distance from the lightning channels that produce it, because higher frequencies are more quickly absorbed by the air. Very close to lightning, the first thunder you hear is from the closest channels, which produce a tearing sound because that thunder contains high frequencies. A few seconds later, you hear a sharp click or a loud crack from lightning. Channels a little farther away. And several tens of seconds later, the thunder from a most distant part of a flash is quieted to low-frequency rumbling. Where does lightning strike? Most, if not all, lightning flashes produced by storms start inside the cloud. If a lightning flash is going to strike ground, a channel develops downward toward the surface. When it gets less than roughly 100 yards of the ground, objects like trees and bushes and buildings start sending up sparks to meet it. When one of the sparks connect the downward developing channel, a huge electrical current surges rapidly down the channel to the object that produces the spark. Tall objects such as trees and skyscrapers are more likely than the surrounding ground to produce one good target. Produce one of the connecting sparks and are more likely to be struck by lightning. Mountains also make good targets. However, this does not always mean tall objects will be struck. Lightning can strike the ground in an open field even if the tree line is close by. Basically, lightning can strike anywhere. What causes lightning? The creation of lightning is a complicated process. We generally know what conditions are needed to produce lightning, but there is still a debate about how exactly how a cloud builds up electrical charges and how lightning forms. Scientists think the initial process for creating charged regions in thunderstorms involves small hair particles called graupel that are roughly 1/4 millimeter to a few millimeters in diameter and are growing by collecting even smaller supercooled liquid droplets. When these graupel particles collide and bounce off smaller ice particles, the graupel gains one sign of charge, and the smaller ice particle gains the other sign of charge. Because the smaller ice particles rise faster in updrafts than the graupel particles, the charge on ice particles separates from the charge on graupel particles, and the charge on ice particles collects above the charge on graupel. Laboratory studies suggest that graupel gains positive charge at temperatures a little colder than 32 degrees Fahrenheit, but gains negative charge at colder temperatures a little higher in the storm. Scientists think the two largest charge regions in the most storms are caused mainly by graupel carrying negative charges in the middle of the storm, and ice particles carrying positive charge in the upper part of the storm. However, a small positive charge region often is below the main negative charge region from graupel gaining positive charge at lower, warmer altitudes. Small ice particles that have collided with negative graupel in the lower region can contribute positive charge to the middle of the storm. A conceptual model shows the electrical charge distribution inside deep convection thunderstorms, developed by NSSL and university scientists. In the main updraft, in and above the red arrow, there are four main charge regions. In the convective region, but outside the outdraft, in and above the blue arrow, there are more than four regions. This is what we are talking about. How is electrical charge distributed through a thunderstorm? That is what we are talking about, guys. A conceptual model shows the electrical charge distribution inside the deep convection thunderstorm developed by NSSL, and university scientists. In the main updraft, in and above the red arrow, there are four main charge regions. In the convective region, but outside the outdraft, in and above the blue arrow, there are more than four charge regions. And that is your Lightning Basics 101. Thanks guys for watching. I hope you have a good day. Be careful out there. See ya.